Welcome to a tutorial on diode clippers. And the clippers, as you know, that we're going to discuss today are used in some wave shaping circuits where we can just remove or slice off parts of the input signal waveform. So imagine this to be an input signal waveform. So if you just pass this through a clipper, okay, and let's say we don't want the second half cycle part, so if we just pass this through a clipper, at the output we shall obtain only the positive half cycle if the clipper is designed that way, and the negative half cycle or the second half cycle part will be just sliced off. So in this way we can just shape off various waves in whichever way we want to, and on top of that we can even use clippers to add certain parts of voltages to an input signal. So it's just based on what our purpose is. Clipper can be designed in many ways. So getting down to the basics, let's just first discuss about how many types of clippers can be designed using diodes. So using diodes we can design basically three types of clippers. So the first one is a series type clipper, second one is the shunt, and the third one is the combinational clipper. Okay, the series type of clipper can be further divided into two types: the positive series type and the negative series type. Similarly, the shunt type clippers can also be divided further into the positive and the negative types. Okay, so that was the classification of clippers based on their design procedures. Okay, so now let's move on to the series type of clippers. Right, so here it is, the series type clipper. Okay, so what we'll do is we'll just compare the positive and the negative series type clipper side by side. So here is the positive type. Okay, positive type clipper, and here is the negative type clipper. Right, so let's see if I just draw the circuit. In the positive series type clipper, circuit looks something like this. Okay, right, so this is the load resistance, and across this we obtain the output voltage. Right, so over here we have the terminals 1 and 2, and this is the output terminals. Okay, so here we can see that okay, let the output terminals be named as 3 and 4. This is grounded. Okay, so this is a circuit of a positive series type clipper, and the negative series type clipper circuit looks somewhat like this. If you just compare the two types of clipper circuits, then you'd find that the diode is just reversed in polarity for each of the different type of clippers. I mean the positive and negative type of series clippers. Okay, other than the direction of the diode, okay, nothing's more different. Right, so let us first imagine the input signal at the input of each of the clippers. Okay, here's our input signal. Okay, so that's a sinusoidal input signal over here. Right, so for the positive series type clipper, what would happen is that when the input signal arrives at the terminals 1 and 2, okay, here the terminal 2 is connected to ground as shown, and so has 0 volts. Same for here. So whenever the first half, or rather the first positive half of the input signal arrives at terminals 1 and 2, then the terminal 1 has a positive voltage compared to terminal 2, and the diode in this case is reverse biased. As a result, it behaves as an open circuit element, so no current flows through the circuit and the output voltage is 0 during the first half cycle. So now when the second half cycle arrives, the polarity across the terminal 1 is reversed and it becomes minus compared to terminal 2, which goes at a positive polarity. Okay, so now at this time the cathode of the diode has a negative voltage, and so it begins to conduct a current through itself. Okay, and so a voltage output occurs across RL with a reverse polarity, as terminal 3 is at the negative polarity while terminal 4 is at positive polarity. So due to this, we obtain a negative output voltage which varies in direct proportion to the second half cycle of the input voltage signal. So look at that. So here we obtain the second half of the input signal, right? On the other hand, in the negative type of clipper, as we can see here, in the negative type clipper, when the first half cycle arrives, the diode is forward biased because the terminal 1 is at positive potential compared to terminal 2, so the anode of the diode has a positive potential across itself, so the diode conducts heavily during this period and a voltage occurs across RL with positive polarity at 3 and negative at 4. So we have an output voltage during this time that corresponds to direct variation in the first half cycle of the input waveform. So it looks somewhat like this. So we have the first half cycle of the input waveform, and now the second half cycle arrives next at the input to the negative type series clipper. So when that happens, okay, so when that happens, terminal 1 is at negative potential compared to terminal 2, which is comparatively at a higher positive potential than terminal 1. Okay, so during this case, since the anode of the diode is at a negative potential, the diode stops conducting since it's reverse biased, and due to that, no current can flow through RL, and hence the output voltage is 0 during this case. So in case of the second half cycle, we have no voltage output. Okay, so there it is. We see here that the negative type series clipper clips off the negative half cycle, while the positive type series clipper clips off the positive first half cycle. So they're rightfully called their names. Okay, now just let's move on to the shunt regulator, the shunt type clipper. Okay, so here we have the shunt. Here we have the shunt type of clipper. Okay, so same as before, we shall compare the positive type and the negative type shunt clippers side by side. Okay, so there it is. So in these two types of clippers, the circuit looks somewhat like this. In case of the positive shunt clipper, there's a series resistance and the load resistance. Okay, this is ground. Okay, terminal 1, 2 at 0 volt. This is 3, that's 4. Okay, here we have our output voltage. We have our load resistance, our series resistance, and here across RL we have a diode connected, okay, which is oriented somewhat in this type of direction. Okay, And in case of the negative type shunt clipper, the circuit looks somewhat like this. Okay, here we have our diode oriented just in the reverse direction to what it's present in the positive type of shunt clipper. Okay, here is the load resistance, the series resistance, terminals 3 and 4, across which we have our output voltage. Okay, so this is terminal 1 and 2 at 0 volt. Alright, so now let's imagine that there is an input signal falling across both of the positive and negative type of shunt clippers. So here we have our input signal, okay, Vi, so which is a sinusoidal input signal, of course. So based on that, when the first half cycle arrives, in case of the positive type of shunt clipper, what happens is terminal 1 is at a positive potential compared to terminal 2. The diode is forward biased and it starts to conduct a heavy amount of current I through itself, and as a result the diode behaves as a short circuit element and the voltage across RL falls to 0. So due to that, what we can understand is that during the first half cycle there is no voltage across the load resistance in the positive type of shunt clipper. Okay, while in case of the negative type of shunt clipper, in the positive half cycle the diode here is reverse biased, since a positive voltage occurs across terminal 1 compared to that of terminal 2. So the diode becomes reverse biased and behaves as an open circuit element. So the current flows through RL, okay, resulting in a voltage drop across RL. So the voltage drop across RL is in the same polarity with the applied input voltage, and thus the first half cycle of the input voltage is obtained at across terminals 3 and 4. Okay, so here it is. Okay, so here is the waveform for the first half cycle. So in the first half cycle the voltage across terminals 3 and 4 are in the same sort of variation along with the input signals first half. Okay, so that's it. So when the second half cycle of the input signal arrives, let's see what happens. When the second half cycle arrives in case of the positive type shunt clipper, the diode in this case, or rather terminal 1, experiences a negative voltage, okay, experiences a negative voltage compared to that of terminal 2, which is at a higher voltage compared to terminal 1. So the diode in this case is reverse biased, as the cathode to the diode has a positive signal on itself. So due to that, since the diode is reverse biased, it behaves as an open circuit element, and the current due to the applied input signal flows through the load resistance in this direction, and as a result generates a voltage across RL in the reverse manner, which is just opposite to the, or rather, yeah, which is the same as the polarity of the second half of the input signal. So in case of the second half of the input signal, we obtain the second half of the input signal across the output of the positive type shunt clipper. So as a result, what happens is that the positive half cycle is completely being clipped off in case of the positive type shunt clipper, and when the second half cycle arrives in case of the negative type shunt clipper, what happens is that for the negative type shunt clipper, the polarity at terminal 1 becomes negative compared to terminal 2, which is a positive potential, than terminal 1. So in that case, here the diode is forward biased and a huge amount of current flows through the diode, and as a result, the diode, just being forward biased, thus behaves as a short circuit element, with the result that across RL the voltage, or rather the output voltage, just drops to 0. So in this case we have no output voltage in the second half cycle of the input signal. So we see that the negative and the positive shunt clippers have successfully been designed to clip the negative and the positive half cycles of the input signal respectively. So here are the graphs representing their output voltages. Okay, so apart from these types of clippers, we have the third type of clipper known as the combination clippers. Okay, so here's our clipper type number 3, that is combination clippers. Okay, in this type of clippers we have, as we will see while drawing the circuit, a series resistance R, okay, and two diodes instead. Okay, we have two diodes instead connected along with a voltage source across each. All right. Yep. So here is the voltage sources connected to the diode lines. Okay. So let this be V1 and let this be V2. Okay. So here's terminals 3 and 4, and here's 1 and terminal 2 at ground voltage. Okay. Now imagine the input to this combination type clipper circuit, a signal input, okay, Vi, a sinusoidal signal input Vi. So as you can see in the circuit that there are two diodes connected with different polarities, okay, connected in reverse order, and so are their cells that are connected across them. So when the first half cycle arrives at the input to this circuit, okay, terminal, okay, so when the first half cycle arrives, so before I move on to that, let me just rectify the polarity of the cells a bit. Okay, this is positive and this is negative, of course, and this should be negative and this one positive. Okay, so yeah, and that looks better. Okay, right, so here are the cells connected across, with the diode this way. So here what happens is that when the first half cycle arrives at the input to this circuit, then what happens is that the diode, okay, let this be called diode D1 and this be called diode D2. So the diode D2 is forward biased, as we have a positive voltage at terminal 1 and a negative voltage at terminal 2. So the diode D2 is forward biased, and since it shorts out, so the cell having voltage V2 over here gets connected to the terminal 3, and for the first half cycle, as the output of this particular circuit was beginning to get along, to vary along with the direct proportion to the first half cycle, it just is clipped off at the voltage level V2. Okay, so it cannot increase beyond the voltage level V2 and gradually decreases down, as does the input signals first half. Okay, so here we have the voltage level V2 at which it's been clipped off, okay, on the positive half. And now when the second half arrives, what happens is that the polarity at terminal 1 and 2 changes. Polarity at terminal 1 becomes negative, and that at terminal 2 becomes comparatively positive with respect to terminal 1. So we have diode D1 forward biased, and therefore, okay, so this is forward biased, and so therefore the cell connected with it having a voltage of potential of V1 is shorted to terminal 3. Okay, so as a result of what happens is that the voltage V1 appears across terminal 3 and 4 during this case. So under this sort of situation, as the output was slowly beginning to vary with direct variation of the second half of the input cycle, so it gets just clipped off at V1 and thereby recedes again, as does the input signal's second half cycle. So here we can see, if we compare the waveforms, that due to the having, or rather due to connecting certain voltage sources to the diodes, as the input signal was beginning to produce an output signal having the same shape as its waveform, the voltage levels, or rather the DC voltage levels present on the cells, has just clipped off the output of the circuit, preventing it from reaching the peak voltages of the input signal. So this type of combination clipper circuit is especially useful, or rather is especially important to be used in case of high power devices, okay, where it's necessary to check, or rather prevent, any kind of surge voltage or current from reaching its peak, so which may sometimes exceed the maximum tolerable limits of circuits. So in that cases, or in case of high power devices, this sort of a concept is highly essential and finds great application in case of power electronics. So that was clippers, and from discussion we see that the clippers over here finds various application apart from wave shaping circuits to certain power devices and protection type devices, as in the case of combination clippers. So keeping this in mind, we come to the end of this tutorial and hope you've enjoyed it. So that's all for now. Thank you.